In this video, we are going to talk about Pat. Pat, who we will represent with subject 3, lives on top of a mountain. Depending on which direction she leaves her home, she can run a loop where she encounters a drastic decline followed by a long, slow incline, or the reverse, a slow decline followed by a more drastic incline. If we observe how her ground reaction force metrics relate across the subset of conditions that describes the first loop she runs, a drastic decline followed by a slow incline, we can highlight a few speeds and add conditions that include a large decline and a slow incline. Across this subset of conditions, higher ground reaction force active peaks correspond to higher max tibial forces, and higher ground reaction force loading rates somewhat correspond to lower max tibial forces. If we compare metrics across the reverse direction of running, a slow decline and a drastic incline, we see that changes in the ground reaction force metrics, like the ground reaction force active peak and the ground reaction force loading rate, really give us mixed results for what they indicate in terms of max tibial bone loading. The main takeaway from this example is that even if ground reaction force metrics indicate changes in tibial force across a certain subset of conditions, it may not be a good indicator across a different subset of conditions, making it an unreliable indicator of internal loading or injury risk. Remember, increases in ground reaction force metrics do not necessarily indicate increases in tibial force.